Hello my dear students, today we are in lecture number 26. It is lecture 26 of chapter 2, same unit, electrostatics. My dear students, in today's lecture we will study about the energy and energy density and then combination of capacitor. How we can get equivalent capacitor at the place of multiple capacitor. If in circuit we are using 5 capacitors of certain value, then can we arrange one capacitor behalf of that 5 capacitance? That is called the equivalent capacitance. We will study today. Student, before starting today's lecture, I would like to give you this simple circuit, my dear student. With the help of this circuit, you will be able to recognize what is the actual view of capacitor. We have studied the 3 types of capacitor: parallel plate capacitor, spherical capacitor, and cylindrical capacitor. In this circuit, actually this circuit I have arranged from tube light circuit. Okay, it was not using from several days. Now you can see, student, I hope you are able to see clearly. This is capacitor and this is a cylindrical capacitor, my dear student. I hope you can see this is the negative terminal. It is written here, the negative. This is the negative written, and the another side it is not mentioned anything. This is negative side, that's why it is written negative over here. I hope you are able to see it is mentioned negative. Okay, my dear student, this capacitor is of I can tell you 10 microfarad, which can withstand over 250 volt. It is mentioned over here. It is 10. If I will keep this near the camera, I hope you can see it is written 10 microfarad in very small. 10 microfarad and 250 volt it can withstand. This is the structure of capacitor, my dear student. This is the cylindrical capacitor. Okay, this is the cylindrical capacitor. This is negative written. You can see this is negative. It is negative, and nothing is written over the other side. So this is the cylindrical capacitor, my dear students. Another capacitor I would like to show you. It is, yes, this one. Let me pull it out. This one, it is parallel plate capacitor. Oh, one terminal is damaged. No, this is parallel plate capacitor, my dear student. You can see it is parallel plate capacitor. The 2 plates are joined parallel in this way, and then it is laminated by alloy material. Remember, of this capacitor, one terminal from here it has been broken. Value of capacitance of this capacitor you cannot read actually. Of this parallel plate capacitor, the capacitance mentioned over here in digits, in number, in code word. Electricians can read and find out the value of capacitance. So this is the parallel plate capacitor. I would like to see you another parallel plate capacitor of the different color. You can see this is also the parallel plate capacitor. Yes, this one. It is connected in my circuit. This is also the parallel plate capacitor, this one. Now I hope that you will be able to find or recognize the capacitors if it is in your circuit. I would like to tell you this one capacitor, this one, another capacitor is this one, and this one is also the capacitor, and this is also capacitor, this one, green one, and uh, there are two more capacitor, the small capacitor by the of green size, you can see over here, it is mentioned over here, this is also capacitor, and these are the diodes that you have to study later on in your course. This is the diode we will study. I hope that I would be able to preserve this circuit so that in future I will show you the diode also. Okay, my dear student, so today lecture we are starting with the uh, topic energy and energy density. My dear student, suppose this is parallel plate capacitor, this one, this is the parallel plate, energy used to store, it is connected with a battery of V volt, energy used to store in this space, in this very space, energy, that is the charge in presence of electric field used to store. Okay, all the quantity you must remember, that is A is the plate area, D is the separation between two plates. I hope you must remember. Now my dear student, if it is the voltage V given between the two plates, suppose at any instant charge starts flowing by the small amount q, and this charge which is flowing towards the plate, it will maintain a potential. What we are going to derive here, energy and energy density, and energy density. Okay, my dear student. So this charge will move to this plate and it will maintain a potential. And what will be that potential? As we know that Q is equals to CV. So potential will be established Q by C. Okay, this potential has been established on this plate. Now what will happen? As we know that to do work, this a small charge has to move from battery. Remember, my dear student, initially capacitor is uncharged. Capacitor is uncharged. Due to potential difference, charge starts moving. Okay, and we have supposed Q charge, a small charge, has been moved to the plate which maintain a potential Q by C. Now, the next charge, that is the elemental charge, will move, and that elemental charge will start storing the energy, that is the potential energy, my dear student. Let us consider, okay, now dq, the very small amount of charge, moves under the potential. dq moves under potential V, and what is that V? It is Q by C. Then what will be the potential energy or work done? We know that if charge dq, it is maintained on the potential V, then this will be the potential energy. Okay, so we are having V as Q by C times dq, this one, and this is the work. Remember, work was 0 when the charge was 0, charge was not start flowing. Fully charged, suppose it is q is the total charge that is to be delivered by the battery. it is the Q, and the total energy will be stored, that is the total work will be considered, and that is U. We are representing by U. What will happen then? dW will be W and U minus 0, that will be the U. C is constant, will be taken out, and Q dQ we will integrate from 0 to Q. What will be the answer? 1 by C. Q dQ will be Q square by 2 from 0 to Q, and this is nothing but half Q square by C. I hope this is not very tough, and this is the formula of energy. Energy is stored by capacitor. Okay, if Q is the full charge, total charge, C the capacitance, then this can be written as this one. Now my dear students, we can change or transform this formula as this one also. Since Q is equals to CV, then you can write this Q as CV, and energy will be half Q square can be written as C square V square over C. So this will be half C V square. This is the another formula of potential energy. U is equals to half CV square. Could you transform this formula in, I'm rubbing this one, in another way? Yes, you can change by replacing the C as Q over V. Okay, replacing that C over Q over V, you will have another formula for the capacitance. Okay, my dear students, so U can be written as half Q square over C, and C can return the Q over V. Q over V, V will be goes up, Q will be cancelled out. So this is half Q V, and this is the another formula of potential energy is stored by capacitor. Now my dear student, we are going to study the energy density. Energy density. Energy density. We'll represent this energy density by this letter. This is actually U, but small u. As we know that mass density is mass per unit volume, so energy density will be represented by or defined by the energy per unit volume. This is the energy per unit volume of the capacitor. Could you tell me, my dear student, what is the volume of capacitor? Volume of capacitor, in which space this capacitor is storing the energy? Yes, actually this capacitor is storing the energy in volume. A is the plate area and this distance is d, so the volume will be A times d, and energy density can be done as the energy is half C V square divided by A into d. Now half C, it is the capacitance, and for parallel plate capacitor we know that C is epsilon naught A by d into V square divided by A into d. So this potential energy can be written as this. A will be cancelled out, half epsilon naught V over d whole square. And what is V over d, my dear student? It is the V by d, which is electric field. So half epsilon naught E square. U is half epsilon naught E square. This also explains the energy stored in presence of electric field, that is the electrostatic energy. This is called electrostatic energy. Remember, my dear students, we have written this V by D as E because we know that E is equals to dV by dx, that is the potential gradient, and this is the potential gradient. dV by dx, or potential by length, or the potential by position. This is the potential and this is the total position, that is the length of the capacitor, which is the separation. So my dear student, this is the potential and potential energy and energy density. Okay, the number of question I'll give you in my assignment. I have given actually in my assignment, while lecture I'll give you few questions. Okay, my dear students. Now the next topic, which is important but very easy, that is the combination of capacitor. Remember, my dear student, you have studied in standard 10th to find combination of resistor. The same procedure will use. You have to keep other certain things which are very simple in your mind. Combination of capacitors. Okay, the first we'll study about the series combination. Series combination. You have to remember, in series combination, two things. I'm drawing here the circuit. We are taking a simple circuit of two capacitors. Okay, here two capacitor C1 and C2. We have connected this two capacitor by a battery of potential V. Okay, my dear student. Okay, if the two capacitor are connected with potential V, what will happen? Charge start moving from here. If charge will start moving from here, this two capacitors suppose draw total charge of Q. How much charge is draw? Total charge it draws Q. Okay, when this charge will go to this one, this charge you have to just be bear in your mind and compare this charge as electron, as there was in standard 10th of equivalent resistance. You consider that quantity which flow through the circuit was current. Okay, here you have to compare with the charge. You know that the charge will first charge this capacitor or flow through this capacitor, and then total charge will again move to this capacitor. Remember, in series charge remain constant, that is total charge remain constant, and that charge, what does it mean by the constant? Actually the total charge reached to the both the capacitor, but this charge will work over here with this capacitance and some potential will be used. Suppose here the potential established V1 and here the potential established it is V2, but this two V1 and V2 has been taken from this cell. It means this V is equals to V1 plus V2. Okay, of this particular derivation, what is our aim? Our aim is to find, can we have one capacitor behalf of this two capacitor? Okay, let us suppose we have one capacitor behalf of this two capacitor, and we will call this capacitor of capacitance C equivalent. Okay, this is also connected with the same battery of potential V. Now this single capacitor will draw the same charge which is drawn by this two capacitor, that is Q. Okay, now the total charge drawn by this capacitor is Q. Okay, one by one we will apply the formula Q is equals to CV for three capacitor, and then we will have the derivation. This is the key point. Remember, for C1, can we write Q is equals to C1 V1? Yes, we can write. And V1 can be written as Q by C1. Q by C1. Similarly, for C2, we can write Q is equals to, because here the charge again Q equals to C2 V2, and this V2 can be written as Q by C2. Now for C equivalent, what we can write? We can write Q is equals to C equivalent into V, and thus V can be written as Q by C equivalent. Okay, yes. Now we have to put this three value V1, V2 and V in this particular equation. Say equation 1. Okay, from equation 1. From equation 1 we can write as Q by C equivalent is equals to Q by C1 plus Q by C2. This Q will be cancelled out. So 1 by C equivalent equals to 1 by C1 plus 1 by C2. So this is the equivalent capacitance when two capacitors are connected in series. Okay student, can you analyze if we had used three capacitor, then what should be the equation? For three capacitor, all the things will be same, but another quantity, another term will be added over here, that is the Q by C3, and then equation will be 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3. It means for n capacitor, remember, it is not necessary that n capacitor will be identical. For n capacitor, you can write for n capacitor. Okay, you can write 1 by C equivalent as 1 by C1 plus 1 by C2 plus here 1 by Cn. Okay, my dear student. Yes, and if we talk about the capacitance for two capacitor, then we should remember this formula, which is important because for two capacitor, the number of times you will use this formula. For two capacitor, from here I'm writing, remember, from here, let me write over here only. 1 by C equivalent, it is C1 C2 LCM and above C1 plus C2. So the C equivalent you have to remember directly, C1 C2 by C1 plus C2. Okay, here C1 C2 by C1 plus C2. If you will use two capacitor identical, okay, for two identical capacitor, for two identical, remember, if I am talking about the identical capacitor, that is C1 equals to C2 equals to C. If two capacitor you will use, you will find C into C. C equivalent will be C square by 2C, that is C by 2. For n capacitor, what will happen? For n identical capacitor, and capacitors, what will happen? The C equivalent will be C by 2, so that will be C by n. For 3 capacitor, it will be C by 3. Remember, I'm talking about the identical capacitor, so C by n. It means when we connect the capacitor in series, remember, in series the capacitance decreases. In series, capacitor decreases. Write in your notebook, in series, capacitance of combination decreases. Now student, we will talk about the parallel combination. Okay, yes, parallel combination. Here we have two capacitors are connected in parallel with the battery of voltage V, capacitance suppose C1, C2. Now the two will draw a charge Q. As this charge will move and reach to this point, this charge will break in two parts because charge has to move through both the capacitor. Suppose it is Q1 and it is Q2. Remember student, you can say, why not sir, half Q and half Q goes? Yes, it may goes. Okay, it may go, but it totally depends upon the capacitor, that capacity of this capacitance, how much charge it draws from the cell. Okay, we have written Q1 and Q2. Now the equivalent capacitance of behalf of these two, let we draw here, and it is connected with the same potential V. This is plus and minus. It is C equivalent and it draw the same charge, how much? Q. For C1 C2 and C equivalent we can write since we have derived already, so I'm not writing in very detail, but you can write directly this for C1 and C2. For C1 it is Q1 equals to C1V. What is constant over here? One thing, okay, charge is divided, charge is distributed, but you can see the terminal of this capacitor. Look at it carefully, it is important. The one terminal of this capacitor is connected by A, the another terminal is connected by B. It means this capacitor has potential difference of VAB. Okay, very good. Now this capacitor, one terminal is connected with A, another terminal is connected with B. It means this has also the potential difference VAB. Now look at this one. Because behalf of this two, we have been put one capacitor over here. This is the terminal A and this is the terminal B. It means this capacitor also one terminal connected with B and another at A and another at B. So this capacitor also has the potential difference VAB. It means voltage is constant. Okay, V is constant, but this charge is divided in two parts, Q1 and Q2. Okay, I hope you are clear about it. Now for C1 it is Q1 is equals to C1V. For C2 we can write Q2 equals to C2V, and for C equivalent we can write Q is equals to C equivalent into V. Now we put this three terms, that is the three, okay, equation in this one. So we'll have this Q equals to Q1 plus Q2, that is the C equivalent equals to the C Q1 C equivalent V equals to C1V plus C2V. Can we cancel out this V by taking common? Okay, because this is common and will be cancelled. C equivalent equals to C1 plus C2. For parallel combination, you are having the equation as C equivalent C1 plus C2. If n capacitor are connected, okay my dear student, then C equivalent will be C1 plus C2 plus Cn. Okay, for n identical capacitor, can you write C equivalent as n into C? Now by this equation we can say the equivalent capacitance in parallel combination, the equivalent capacitance increases. Okay my dear students, parallel combination, you can say the equivalent capacitance increases. As it was in series, the net capacitance decreases, and here you can see it is increasing. Now the very simple example I'm giving you. Next day my dear students, that is in next lecture, we will study the mixed combination. Okay, after solving few questions we'll move for the mixed combination. Now this is your homework I'm leaving you. Three capacitors, C1 it is 9 microfarad, C2 3 microfarad, or the identical, let three identical capacitors are first connected in series, then in parallel. Okay, find ratio of C equivalent for C series to C parallel. Okay, this is your homework. You have to solve. If three identical capacitor are connected in this way, okay, then you have to find the ratio of C equivalent. Okay, my dear students, in next lecture we will study about the mixed combination, and then we will solve few questions to find capacitance, charge on each capacitor, potential on each capacitor individually. Okay, my dear students, thank you very much.